Okay, we have here today another problem in the playlist for limits and continuity, and we're asked to find, is 1 over x squared continuous? And if it is continuous or it's not continuous, why? So to start with, the short answer for this is just going to be a simple no. 1 over x squared is not continuous, just looking at our graph over here to the right. And the first thing I want to do is actually use this graph. We have the informal definition for continuity that says if the curve is continuous, we should be able to draw it without lifting our pen. So if I just kind of trace this curve with my pen in blue, well, the problem is even when this is going off to infinity and these two lines get closer and closer here, they never connect. So at some point we have to do this and we're not following the curve. So basically, even if we could draw all the way to infinity somehow, we've got no way to draw this without lifting our pen. But now, again, this definition from the graph is pretty informal. And so let's use the more formal definition instead, which tells us for a curve to be continuous, we need the limit as x approaches a of f of x just equal f of a. So this is going to be true on our curve at some point. Like if we have an a out here somewhere, well, the limit around here, if we say this is our f of a value right here, well, the limit here is going to be the same as actually f of a. So at this point, a, it's continuous if our a is over here. But in our case, we're really concerned about 0. That's where we have this vertical asymptote. What happens when the limit as x approaches 0 of our 1 over x squared curve? What happens here? And now if you imagine plugging in numbers on the left side and right side really close to 0, well, in both cases, you can see the curves going off to infinity. So this limit here is actually going to infinity. And then so for our f of a, where a is 0, we want to check what's happening, what's our f of 0 value. Now you may want to say that f of 0 is infinity, but we really only use this notation for a limit. So for f of 0, we really can't do it that way. We just have to say it's undefined or does not exist there. This is our normal like divide by 0 case. So we just say, so f of 0, we just say does not exist. So what's going on here is there's some implied conditions beyond just this to know about. So like for example, f of a has to exist for this to work. Otherwise, we've got no way to have equality here. So we also have to have this limit of f of x has to exist. And so we violated this condition. Our f of a value does not exist, but actually this limit doesn't exist either. We use infinity here just as a notation to like get some understanding of what's going on, but still this limit doesn't exist. And so neither of these conditions apply, and so this doesn't apply. And for all these reasons here, this is why this curve is discontinuous. One last thing before we finish. In the other video I did on continuity, I mentioned some discontinuities. I mentioned the jump discontinuity. I mentioned the removable discontinuity, but I didn't mention this kind of discontinuity, which is an infinite discontinuity. When we have a vertical asymptote here, we can't be continuous at this point where we're going off to infinity. And so this is our infinite discontinuity. So we'll stop it there. Thanks everyone for watching. Have a good day.